Good morning, good day, and good evening, everybody, and thank you for tuning in to another one of these physical material series tutorials. In this one, we'll be creating this translucent looking plastic material that you see on this cup here, and we'd like to thank Tom for sacrificing a couple of his cups for this photo shoot, because, whenever you're creating materials, it's always good to have solid visual references in front of you. So if we just quickly analyze what we see, we can probably gather that this is a green plastic material of sorts. The reflections look kind of rougher. There's a strong translucent component to the material, so there's probably going to be some fiddling with some form of scattering there. And by and large, that's kind of all that there is to it. There's bumps and bruises on the cup as well, but we won't really worry about those since we already know how to use bump maps at this point, and that's just extra detailing right there. So how about we go to work here? Let's create a new physical material. Let's apply it to our glass object there, and then let's also drag it into the Corona Node material editor. Now, first, let's make sure our metalness mode here is set correctly. We're going to be creating a plastic material, so non-metal is the option we're going to want to go with. Okay. Now, the main feature for this material is probably going to be that translucent look. And if we enable subsurface scattering, and if we increase the radius for it, okay, well, you'll see that, yes, we're getting that diffuse-like translucent look where the light is passing through the cup. But if we compare this effect to the reference images, well, you'll probably notice that our plastic cup looks a bit more refractive than what we have in front of us in the interactive render right now. So subsurface scattering is going to be too diffuse for us here. Or in other words, the light coming through the cup like this is just too spread out. It's too rough, if you will. Our reference looks more refractive than what we got here right now. And that's basically because, well, the subsurface scattering channel is a better fit for thicker, opaque materials such as marble or skin, and not so much for these really translucent looking materials, okay? Okay, so that means we won't be relying on subsurface scattering for this material, and instead we're gonna make it refractive. All right. Right. So immediately you can kind of see that this is now looking a bit more like it should. Now, yes, the material is refractive, but it's super rough, as you can see. So it's not really glass-like at all, which is kind of exactly what we need here. Now, we could lower the roughness down a bit. So let's go under the base layer here, and let's just lower the roughness to say, let's try 60%, and let's see how that's looking. Okay, we could lower the roughness down to maybe 40%. I think that's going to look even more like our reference. Okay, so that's looking sort of good there right now, but we'll want to tweak the color here a bit because, our reference was green. So because we are dealing with a refractive object, adjusting the base color here won't really do much for us. All right, which means we'll have to get that color in through different means. And so we're going to do that in a very physical way. We're going to do that by enabling volumetric scattering. Okay. Now, the first parameter that we're going to want to tweak in here is going to be the absorption parameter. So let's give it a nice greenish color. Okay, so we're going to play with the hue, and then we're going to up the saturation here. We want it to be pretty green, so something like this could work. And alternatively, we could also just use the sample tool here and sample the color directly from our reference image. But I think the green color we've dialed in here is going to work pretty fine for us, so let's just go with it. All right. So with the absorption color now dialed in, our interactive renderer, well, nothing changed, right? And so that is because with the absorption parameter, we need to dial in the distance as well, because those two work in tandem. So it's going to be some trial and error here whenever you're going to want to dial the distance in, just because, you're going to want to input a value, and then you're going to want to see the results. Okay, so at a value of 10 centimeters, that's that's still a little too much. So we could lower the distance down to maybe 2 centimeters. Let's see what kind of an effect that has on our material. Okay, and we're getting somewhere here, right? Let's maybe lower down the distance to maybe 0.35 centimeters. Let's just see how that's looking. All right, and I think we're getting somewhere. Okay. Now, the way absorption works is it basically defines the color of the ray that's traveling through the surface. And with the distance parameter, you're basically defining the distance at which that absorption will be exactly that color you've specified. If a ray is going to travel further into the object itself, so basically if it travels deeper than those 0.35 centimeters, well then that ray will get even more and more absorbed than it already is. And it'll do that until it gets completely absorbed. And at that point, your material will start looking black. And do note, this is exactly how these things happen in the real world as well. Right, so the material is looking kind of great, but we'll still want to tweak the scattering color, because the scattering color will basically enable volumetric / subsurface scattering in a sense, which will add even more realism to our material here, because now when the ray is going to bounce around inside our material, its color will get multiplied by the color we set here. And again, this is physically accurate behavior. So what we'll do here is we're going to take our absorption color and we're just going to copy it into the scattering color slot. Okay, so let's see how that's looking. And it's looking kind of cool, but we could adjust the scattering color a little bit. So this is just kind of the color that's on the inside of our material. So let's maybe set it to be a little bit more greenish or so. Maybe we could up the value here a little bit. Okay. And so immediately you're going to notice now that this material is really starting to look like our reference. It is green, it is nicely translucent, and that translucency is sort of green tinted as well in a way, right? So our material here, if we compare it to our reference, you can immediately see that it's behaving much the same as the reference. Now, with translucent materials such as this one, it is always a good idea to emphasize the lighting in a way so that the lighting will emphasize the translucency a bit. And you do that for testing purposes, just to have a bit of a better idea of how the translucency in your material behaves. It's also useful to kind of mimic the lighting scenario from your reference images. It doesn't have to be too precise, although, you know, if you really get it matching, then you'll really be able to compare how your material behaves to the reference in great detail, right? But what we'll do here is we're gonna just do a crude approximation of the lighting that we have in the references. So we'll just move our camera so that the cup is in front of the window as it was in the reference. And to further emphasize the translucent effect, we have a small coronal light in the shape of a sphere right behind our cup here. And if we enable it, you can kind of see how that translucency behaves. And if we compare it to the photo Tom took of his cup, well, you can notice that it's behaving very similarly to the real world thing. Again, though, this is just a crude approximation of the setup in the image. If we really wanted to create pretty much an identical material, well, we'd probably spend a lot more time on getting a similar lighting scenario going, just so we can make sure that our material is behaving as close as possible to the real thing. But at that point, you know, you're just trying to be creative. You're dialing in the details and you're hunting for that perfection. The workflow then consists of you tweaking pretty much the same parameters we've tweaked here, so the workflow stays the same. One thing to maybe note is that these types of plastic cups typically have a glossier clear coat to them that makes them appear a bit more shiny. And to set that up, well, you just need to enable the clear coat layer, right? And then maybe you just lower its value down, its amount value, just so you know it appears like the clear coat is not quite as thick. It's a little bit less reflective. And maybe you want to add some roughness to it as well for that slight extra realism. But again, At this point, you're being creative and you're detailing things. As far as this tutorial goes, well, you hopefully now have a basic idea of how to set up similar plastic materials. Thank you for tuning in. We hope you've learned something new, and as always, take care, good people.